in?
Now.
Okay, now we're live. Okay, so we have lesson 4 and lesson 5 to go over. Well, first off, do you guys have any questions at all? Or not specifically 4 and 5, but any questions at all?
Just still working on understanding the lesson 5. Lesson 4 I've got.
Yeah. Same.
Okay. So do you guys, okay, so we're going to start with lesson 4, and I guess it's number 5 because we have to upload that thing for the second part of the lesson. This, I don't know how this is going to be really hard other than to not look at your paper, I guess. So I'm going to just say value, count, and then the value times the probability. Does that make sense? I'm just going to go over the table.
Sorry, one more time, Jeanette.
Okay, I'm going to, for number 5, on part 2, I'm going to go over, on lesson 4, I'm going to go over just the table for value 1, 2, 3, and 4. Do you guys have any questions on that first, before we start going over the table?
Hold up, sorry.
No? Okay.
And 1, 2, 3, and 4, you said?
Yeah, it's the dice, the variable, the dice one. So
yeah, I'm okay
value
with that
1 is, well, how many times will you get 1 if you roll the dice is a 1/4 or 0.25, and then the value is 1 times 0.25 is 0.25. 2 and 1/4, 0.25. 2 times 2.2 is 0.5. 3, the same count. It's all 0.25, and then the value times the prop. So it's 3 times 0.25 is 0.75, and then 4 is 4 times 0.25 equals 1, and you add all those up, and it is 2.5.
Yep.
Okay. Okay, value. The number 6 is 1, 2, 3, 4 is in the same. It's the same as the table, except we have the variance at the end. Okay. So the variance for 1 is 0.5625, and then for 2 is 0.0625, and 3 is 0.0625, and 4 is 0.5625, which the variance is 1.25, and then to get the standard deviation, the square root of 1.25 equals 1.118. Is that what everybody got?
Yeah.
Yeah.
Okay, so we understand that. So you guys just want to take that quiz then? Because that's it.
Okay.
Okay. Alright, now I have to find that.
I
have so many windows pulled up in here. I know, me too.
Is it the one under? Is it the one under group meeting?
Yeah.
Yeah, it's lesson 4 under group meeting.
Well, I got number 1 and number 2 just right. Okay.
The kids are going to bed, so. This is taking forever. Okay.
How many kids do you
Here
have?
We go. 3.
I had no
idea. That was my oldest.
Oh.
I know, she looks really young, huh?
I know. I thought they were her brothers and sisters.
Oh, thanks.
I thought I was the oldie goldie in here. So.
Oh no. I'm waiting for the other 2 to come Wilson here pretty soon.
Okay, so.
Okay. So no, give all your probability answers in decimals. For example, 0.1234. Do not give probability answers as percents. Human blood can be classified into one of 4 basic types: O, A, B, and AB. The portion of people in the population of the United States which each of these blood types is summarized in the following table. Use the data to answer the following questions. The blood types and the proportions given in the table above define a probability distribution.
I think that's true.
True.
Numbers add up to 1.
Yep.
Yep, it does.
Okay.
Does it? Did somebody do it?
Yeah, it does.
It does? Okay.
Yeah.
What is the probability that a randomly selected person in the United States has a type O blood round to the 2 decimal places? Okay. Probability.
Oh.
So you can just do 1 minus the blood type of O.
Oh, yeah. It's kind of what
No, wait.
What?
You would do 1 minus the probability of A plus B plus AB. Right?
Right. Or you can add them up and then some, yeah. Whatever.
So is it 0.55?
Point. Hold on, let me see something.
Hold on.
I'm gonna grab my notepad real quick.
Okay.
Look through my notes.
I got 0.45. Which. What?
Okay. We're
Hang on.
What? What'd you say, Chelsea?
Sorry, I said we're allowed to use our notes, right?
Yes.
Okay. Did you guys already answer question 4 and move on without me or no?
We're waiting.
I think we're waiting.
Okay.
This is funny because I gave blood today. That's just funny. And I have O blood, so that's hilarious.
Today's about you, Jeanette.
Yeah, I know, right? So, did you guys get 0.45?
Yes.
I did.
Okay, what is the probability that a randomly selected person will not have type O blood around to 2 decimal places?
0.55?
Yeah, 0.55. As this seems really easy to me, and I'm questioning why it seems so easy.
I know. I love the numbers, because I was wondering the same thing. When all the numbers add up, it's more than 1. Like 0.45 plus 0.4 plus 0.11 plus point. Oh, wait a second. No, I did it wrong. 1 second.
Okay. I'm going to re-add 2 because mine equals 1. Mine equals 1.
Okay.
Yeah, mine's
Let's go
1.
on. Yeah, it's
Okay, yeah, I added it wrong the first time. Okay, that's good.
okay. We're all. I did that in the homework too, and I'm like, what is going on? Why can't I? This is ridiculous. I was doing it wrong.
Miss all these questions because of like a simple mistake, you know? Because it seems really easy.
Right, and then I questioned. Well, that was really easy. I think I'm wrong now.
Especially after that.
Yeah.
That's horrible, but true. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from the bladder cancer patient. Tango, one of the dogs, demonstrated this identification of the specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Answer the following questions. If the dogs guess at random, what is the probability they will correctly identify the dish containing the specimen from the bladder cancer patient?
So 1,
1 out of 6, which is
Because there's 7. Yeah, because
Right.
there's 7. What?
Right.
7?
So
But there were
1,
7 bowls containing urine were lined up in random order.
Oh,
So
there was
7 bowls. Okay, so 1 out of
6 were from. Okay, yeah.
So it's 1 out of 7.
1.43.
0.143, yeah.
0.143?
0.143, yeah.
That was kind of a weird question.
Yeah, that was a really weird example. Like bowls of urine and dogs. It's weird.
Oh, but it says round to the. Oh, you guys, it was supposed to round to. Oh, 3 decimal places. Okay.
3.
Usually it's 2. Sorry. Okay.
It's all
Just
good.
making sure. That seemed too easy again.
Yeah.
In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this very well random choice alone, which is the following statement is most appropriate. This provides strong evidence that dogs can detect bladder cancer. There is a little evidence that dogs can detect bladder cancer.
Well, it would be the first one, wouldn't it? Because it's, well, from cancer patients, 22 times.
But out of 54 out of 22, that's not a very good chance.
Yeah,
They're
I
right
would say.
41% of the time, which, I mean, is pretty good,
It's still, yeah, but it's still under.
but it's not halfway.
Yeah, I would say.
This is kind of
down.
I say
Which
there's
one?
little evidence that dogs can detect bladder cancer.
this is
Yeah,
a
I
lot
would
like the
say that.
example we used in the discussion.
Sorry,
was
I
that,
didn't hear
Shannon?
you. What'd you say?
Sorry, I was going to say this is a lot like one of the examples he used in one of the discussions, and it was a little confusing to me, and it did go to the one that says there's little evidence,
Yeah.
Okay.
if I remember correct.
Yeah, let's do
Yeah,
that one.
because it was the boy and girl, like the boy, the girl, right? That one, Shancy, is that what you're talking about?
Was that in last night's broadcast? Because I watched it and I didn't remember an example about that.
No, it was in
Last week.
last week's
Yeah.
broadcast.
Okay.
Yeah, I remember that.
Okay. So let's go with there's little evidence then, right?
Okay. All right, is everybody done with that one?
Yes.
Yep.
I'm hearing my echo. It's really throwing me off. M&Ms are small chocolate candies. Yes, and I love them a lot. The M&Ms previously indicated that in the United States, the distribution of the colors in the bag of M&Ms is given in the following table. See below. If you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy?
I swear this was somewhere as well.
It should
Yeah,
be
this was-
0.13 or 13% because it's got all of the totals there. So the only one that we don't know is green.
Green.
That's
We
the
gotta figure
most
out green.
anyway.
It's 0.16 is green.
Yeah, I got green as 0.16. I got 0.13 for red.
Of drawing a red-colored candy.
Mm-hmm. And then
Okay, you got green was I got 0.16.
Yeah.
yeah, that's what I got.
Okay, and then will they want red?
Red should
Yeah.
be just what it is right there. It should be 0.13.
0.13.
Dippers.
And then the probability of it not being green would be 1 minus the probability of green. So 1 minus 0.16 is 0.84.
184.
That's what I got. Y'all may want to double check.
Yep, that's what I got too.
Okay.
Oh, what did we say on number 8? Was it 0.13?
Number 8 was
Yeah.
0.13, we said.
Correct.
Okay,
Yep.
that's what I got.
Number 9 is 0.84. Is
No,
everybody caught up
number-
now?
Number 9 was 0.16.
0.16.
Yeah. Yeah, 0.16.
Okay.
Oh
And then
yeah, I did not enter it correctly. Okay, thanks guys. And then so 10 is
It's 0.84.
0.84, the one I had there. Okay. Helps if I put the answers in in the correct slot. Okay.
Usually.
The ACT scores of the students admitted to a medium-sized public university in the western United States were taken from Calpix.com. The following summary statistics were calculated. Use the information above for the next questions. Okay, half of the observations are less than or equal to what number?
Okay, so on a standard distribution, the median is the middle, and so half of them would be less than the median, which is 24.
12. So half of 24 is 12.
Well, but you wouldn't divide it in half because 24 is
Because
just
the median already is the 24.
right, and so
Okay.
it would be like if you looked at the bell curve, 24 would be in the middle, so all the ones to the other side would be 24 or less, right?
Mhm.
Is that okay?
Right. That's how I understand it.
So we right. So the answer is 24.
Yeah.
Mm-hmm.
Because if 24 is in the middle of the graph,
Mhm.
then half of those would be less than that. Based on the information on the table above, the top 25% of students scored above what number?
Okay, so top 25 would be the third quartile,
Yeah, so 27.
27.
Yep. Yeah, because that's 75%. Then 75 minus 25, yeah, it's 100. Or 75 plus 25 is 100.
Mhm.
Okay, so which of the following statements is not one of the 3 rules of probability? The third one. If the probability is high, then the probability is positive. Wait. If the probability is low, then the probability is negative.
Yeah, that's not one of the rules.
That.
Yeah.
I don't know if it's the third one for everybody, so that's why I read it.
Yeah. For me, it's the third one.
Because I've had classes where they're messed up, so you say the third one, and then they get it wrong. And
Yeah.
So I'm like, sorry, should I read it out? Okay, well, I guess that's it. I guess we're ready to submit it then?
Wait. I just submitted. Number 7 is it provides strong evidence that the dogs can detect bladder cancer.
What? Are you serious? It's only 22 out of 54, though.
But that's
Yeah,
40%.
that's weird.
I mean, that's not bad. I could have seen it going either way.
Yeah. Yeah, well, and kind of, that's why I was like, it kind of gives away a little bit because it says it is very unlikely that the dog would do this well by random choices alone, by random chance alone. But yeah, that one I totally could see.
Well, thanks,
going
Mark.
either way.
You guys, I submitted it, so.
All right, here we go. I always save for later and then I do it, just because they always tell you to do that.
Well, if
And
I
I've had
save for
a
later,
time where
really?
I didn't.
I had a teacher
I
that
just
always
started
told
on.
us to save for later.
Why
Yeah.
would you do that?
Well,
She
you
said
save for later and
sometimes
then you
things pop
go
off.
and submit it. Well, I had one time where I didn't save it for later, and then something like a glitch with the computer happened, and it deleted all of it
Oh.
and didn't
Oh,
let me
that's-
submit it. Yeah.
Oh.
So
That stinks.
yeah, when I went back in, it's like half of my answers were there, and the other half wasn't there, so I had to like redo it. So that's why they just say always save for later. That way, even if a glitch happens, then it's still saved.
Oh. Well, that's good to know. I've never heard that before.
Okay, not too bad. We got a 93.
Wait, y'all got a 93? I should have got
I got
100.
93.
I got 100.
What did I type in wrong? Number 9.
What does number 9 say?
I put in .8.
Probability.
Oh.
Yeah, that's why. It's all good. 93.
Okay, so we're under tornado watch right now.
Holy
So
crap!
if I go,
That's so scary.
hey, I gotta go, the sirens are going off, you're just, guys, you're gonna have to keep going without me, I guess.
Oh, yikes.
I don't know. It's really weird looking outside right now.
It's all green.
Yeah, it's green outside. We've had thunderstorms and stuff all day.
Can you just show me?
You want to see?
Yeah. I remember my husband was, when he was serving his mission there,
Can you see?
not really.
Not really.
I mean, like, we can see, but not, like,
What
detailed.
color it is? It's all
Yeah.
funky outside. No mirror on.
Ooh, scary. Yeah, well, maybe you should get away from the window.
Oh, you'll hear it coming. We've been having, it's been a crazy day. We've had thunderstorms, lightning, flooding, earthquakes, and now we're under tornado watch.
Oh. We've experienced it
Welcome
all.
to Oklahoma.
Okay. Well, then let's try
Oh.
and get this done, just in case Jeanette has to run to her little basement thing out in the back.
I don't have one. We don't have a
What?
storm
Is this
shelter.
like a requirement?
No. We have to go in. Well, actually, we have a basement, which nobody has a basement here in Oklahoma. So we run down into the bathroom and get into the bathtub and put our motorcycle helmets on.
I was just going to say, dude.
Oh, yeah. It's always interesting. Life is never dull. Okay. Yeah. Anyways. Okay, so number 5, or lesson number 5 in the prep. Where is number 2? Oh, it's right there. Okay, so number 6. So what was Mark was saying that there is we're finding z score for everything, and we just have this. We have to the formula we have to plug in, and so you have to think about what the question is asking you, and then plug in the numbers and go from there. So does anybody have any questions to start off with?
Nope.
Nope.
I'm not great at this yet, but because I've only got to do most of this, but I still have to play with it a little bit more, but let's go ahead.
What helped me was I'm sitting there going, some of the number 7, like D, E, and F, I went and looked at the videos where he goes over the problem. You guys familiar with that? It's I don't know what it's like a what do they call those?
The supplemental helps.
Supplemental videos or helps or questions or something like that. So he is a guy at the board and he goes over and he does it for you. So I'm like, that is awesome. So that really helped me out.
Yeah,
Okay, so
that one.
Yeah, those are awesome. I love those. Sometimes I look at those or look at the videos before I read all the text, because then the text makes better sense to me. Does that make sense?
Yeah, I should try that.
The videos, and then I read the textbook, because the textbook is Greek to me sometimes.
Oh, yeah.
Okay, so number 6. The mean score of all GRE scores is 150.8 with a standard deviation of 8.8. A. Scores of the quantitative portion of the GRE are approximately normally distributed with mean of mu of 150.8 and a standard deviation of 8.8. So that's just right in the question.
Right.
Okay. B. What portion of the people who take the quantitative portion of the GRE will score above 165? So you just plug it into the formula. I'm still hearing myself echo. Should I get closer? Maybe that should help. Okay, so 165 minus 150.8 divided by 8.8 is 1.6136, and then you put it into the applet, and then it's 0.0533. No, I'm super close. Okay. But I'm not echoing anymore, so that's good. Did everybody get that?
Yeah, I just double checked. I got 0.0533.
Yeah.
Okay. Yes. Okay, so C, if a student's score is in the 10th percentile, what would their corresponding Z score be? So you put that put that one in the applet, and you put it in the 10% goes on top, so it's 0.10, and it spits out the number negative 1.282.
That's what I got.
Okay. Fancy? Yeah. Justin? Yeah. Okay. D was thinking, going, what? What is the quantitative GRE score for the student who scores in the 10th percentile? So you take C, your negative 1.282, and that's your Z in your equation. And then you plug in all the other numbers. So it's negative 1.282 equals X minus 150.8 over or divided by 8.8. I wrote on the back because I write large. Okay, so then you take the 8.8 and you put it on the other side of the equal sign. So you get 8.8, and then in parentheses you have negative 1.282 equals x, subtract 150.8. And then you take the 150.8 and you add that to the other side. So your full equation at the end is 8.8 parenthesis minus 1.82 parenthesis plus 8.5 or 150.8 equals 139.5 is your x.
Hang on, I'm gonna double check it just really quick. That sounds right, but I just want to plug the numbers in.
Okay. It looks like this. If you can you see this?
Sort of.
Keep talking so that we can.
Oh, I have to keep talking. Oh yeah, okay, I have to keep talking. Can you see it or not?
Yeah.
I don't know. Yeah. So it looks like that,
So it should get.
all written out like that. So if I keep talking, you can still see my screen because I have to keep talking. I can see my screen. Does that make sense, or should I go over that again?
I got 139.521.
To what? Okay. Yeah, because you
get
got 139.52.
Okay, the 139.5 is correct. I just can't remember my algebra, and I'm like going, okay, what am I have to do now? Okay, so that's D. Okay, that's the last one. So now we're on to number 7. The mean speed of hydrogen at room temperature is 1,800 meters per second with a standard deviation of 600 meters per second. Okay, A. At room temperature, the mean speed of hydrogen particles is approximately normal with a population mean of 1,800 meters per second and a standard deviation of 600 meters per second. So just plug in the numbers from the question above. Has everybody got that?
Mm-hmm.
Okay. So B, what is the probability that a random selected particle has a speed over 2,500 meters per second? So you have to use the z-score again, that formula, and so you plug in the numbers. So it's 2,500 minus 1,800 over 600 equals 1.167. And you go to the applet and you put in 1.167 and it's over, so you get all the way to the right, so you have to shade the right, and then the answer is for the area is 0.1216.
That's what I got.
Okay. I feel like I'm really I'm in your face. Okay, Shancy, Chelsea, we're good?
Yep.
Alright. What is the probability that a randomly selected particle has a speed that is less than 2,500 meters per second? So you take what you had in B, which is 0.1216, which is faster, and then you take the probability of slower, which is 1 minus the 0.12 equals 784. Is that right?
I got
I don't know.
What did you get, Mark?
Jeanette.
I got 0.8784.
Okay, that's it. I got it.
Okay.
Yeah. Okay, that's right. It didn't look right. You see? I'll be down when I can. You can just. They can't see you. They can only see me. Okay. I love you, honey.
Me too.
Can you have Dad do your hair?
No, he does not do it good.
Okay, I'll read and then I'll be down, okay, babe?
Okay.
Just have
Right.
have Dad watch the videos where they do it with the vacuum cleaner.
Oh,
I've seen that one.
I showed him that already. She's got, it's like almost down to her bum, so he doesn't know what to do with all of it. Okay. Okay, so C was 0.8784. D is. You guys have any questions on C?
I'm slow on this. I'm going to be studying it some more, but I'm doing okay.
Okay, so the C is one of the 3 rules, and since we already found out the faster, and then you need to find out the so you have your faster, and then you just have to take the subtract the fastest, and then you have what's left over. Does that make sense? Okay.
Yeah.
Okay, D. What is the probability that a random selected particle has a speed that is less than 1,500 meters per second? So you do the z-score again, and you plug in the numbers. So 1,500 minus 1,800 divided by 600 equals negative 0.5.
Right.
And then you plug that. You go to the applet again, and you plug in the number again below. Because the top is percent and the below is you put the z numbers in there. And it's less than, so you shade in all the way to the left, and then you put in 0.3085.
That's what I got.
Okay, and then on top, then you just look at what the percent says, and it's, which is 0.3085, and that's 30.8% chance. You just move the decimal places 2 places over and you get to your percentile. Okay. I'm glad we have that applet. That's awesome.
That helps a lot.
I know, you just plug in the number. But what gets me is if you don't get B right, then you don't get C right. You know? Because it all builds on each other. So that was frustrating to me. Okay, E, what is the probability that a randomly selected particle has a speed that is between 1,500 and 2,500 meters per second? So then you have to go back and you have to take C, which is 0.8784. That's what is wrong. 8784, and you minus the D, which is 0.3085. And that equals... I put a 3 instead of a 4, so my wrong number is wrong. So 0.8784 minus 0.3085 equals 0.5699. Is that right?
That's what I got.
Okay. All right, questions on that? Anybody?
We're good.
Okay. And F, what is the third quartile of the speeds of hydrogen at room temperature? Okay, so you go to the applet, and it's the third quartile, which is 75%, which is 0.75. And then you know how... Oh, I did a little picture, because I did the bell-shaped. Well, maybe I'll just show it to you guys. Can you see this? On my side, right here, right there. Okay, if you look on the side, I did the bell-shaped, and then I did the 75%, which is here, and then the 25%, which was right there, and we want to know what that area in there was. Okay, so you gotta fill in your z-score thing again. So it's 0.6745, and then x, subtract the 1,800 over 600. Where did I get the 0.6745
Where did you get 0.6745 from?
I don't know.
Is that from a different...
Oh, that's
the
from...
z-score?
If
From
you go
what?
to the applet, I think if you go to the applet and you put in the area as 0.75, then yeah, okay. So
Is that where I got it from?
yeah, so
Is that the 75%?
yeah, you plug in 0.75 for the 75th percentile into the area, and then it shades it in and it gives you the z-score.
Which is the 0.6745, right?
Right.
Yeah,
Okay.
round it up. 4, 5.
Run it. Okay. So then you put that in. Use that as your z-score is the 0.6745, and then you plug in using your what's a jigget? What's that thing called? Z equals. I lost it. Okay. So then you plug it in to your ratio, and then so it's x. So it's x equal or z is
Equals.
0.6745. X is blank because that's what you're trying to find. Subtract 1800 over 600. And then you have to do your algebraic again. And then you move the 600 over to the other side. And you move the 1800 plus 1800. So it's 600 with parentheses 0.6745 parentheses plus 1800 equals 2,204 meters per second.
2204.694.
Yeah, I just rounded to 2204. I didn't put any.
Yeah, I got the same thing.
Okay.
Mhm.
Is it? That's what you got, Mark?
That's what I got, yeah.
Yeah. Okay. Plus 1800 equals 22. Yeah. Okay. And then we go on to the QQ plots. You guys ready for the QQ plots?
Yeah.
Yeah, ready to bust these out? Okay. Plot A, that is not normal. B, that's not normal. And all the other ones are normal.
Yeah.
Is that what you guys got too?
Yeah.
So basically, if it goes from left to right in an upward pattern and there's not too many bunch of crazy guys and zigs and zags, it's normal.
Mhm.
That's how I understand
That
it,
was-
at least.
Yeah. It was pretty easy.
And that's it for that one. You guys ready to take the quiz for the homework? Or?
Do you guys still think E's normal? Sorry. E's
Yeah,
kind
he
of
froze up.
Even, well, let me look up the answer key.
I mean, E kind of has it going on, but it is
normal.
kind of little,
Wait,
kind of goofy.
yeah, E is not normal.
No, it's not normal?
It's not normal, yeah.
Because of the zigs or the uptick in it?
The
Right.
little lump-looking thing.
Well, my printer's not the best. I cannot. Like, seriously, I made pencil lines so you can see what I'm talking about, but you can't see what my printer actually printed off, can you? No. So I'm like, that looks about right, sure. Okay. Okay, so A, B, and E are not normal.
Yeah.
Okay. You guys feel comfortable taking the quiz or the homework? What do they call that?
Give it a shot.
Why not,
Oh, the
right?
group meeting. The group meeting.
Yeah.
Okay. This takes a long time.
Because you have the app open, huh?
Yeah.
The desktop thing, VMware.
And I have like 20 bazillion windows open on my computer right now.
I know, me too.
Here it is. Okay. And that's like, in less lesson, we're supposed to use the normal probability applet as well. So now we have to open that up. Or I think I have that open someplace else.
Yeah. Oh, how am I supposed to fit all this on my screen and still see you guys?
Okay. Okay, I'm gonna start it. Okay, let me know when you guys are on number 3 when you're ready to start number 3, because it took
Ready.
my computer a while to pull that up.
Okay, ready.
Okay, I'm ready for number
Ready.
3.
Me too.
You guys are ready? Okay. The total area under a density curve must equal
1.
1.
Mm-hmm.
Do we put do we put the number in, or do we write 1 O-N-E?
Put the number in.
I just put the number in.
Okay. Okay. Under certain circumstances, a density curve can drop below the x-axis.
I
That's
think
false,
that's
right?
False.
Because he was saying something about that in the discussion yesterday, wasn't he, Jeanette?
That it could be true.
It
No.
has to stay above because the x is a horizontal axis.
Right. You can't have a negative value. You can have a negative
Right.
z-score, but you can't have, like, I don't know, because it has to equal 1. So it's not like you would have negative data.
Right, exactly.
So he was saying something about when it comes down close to the axis, it stays positive. I can't remember how he said it or what he said.
Well, I just remember when I was looking at the reading, it talked a little bit about it as well. Like it could drop low, but I'm see if I'm finding. But I believe that, like from what I remember, it can't go below.
Because even using the 68, 95, 99.7 rule, like even those two little tips right above the x-axis, that's still positive value. It's just like a 0.3 for both of those little things.
Yeah.
Okay, so number 4 is false, is it?
Yeah.
Right.
I would say so.
Okay, number 5, a normal density curve is symmetric, which is a bell curve.
True.
Come on. There we go.
Okay. Use the following image to answer questions 6 and 7. Number 6. Which of the following elements of the figure represents the z-score in the image? C.
Let's see. Yeah.
Yeah.
Okay, number 7. Which of the following elements of the figure represents the probability that the random variable z will be greater than 1?
B.
I think B
Yep.
as well.
B it is. According to the 68, 95, 97, 99.7 rule, what portion of the data from the bell-shaped distribution will be within 1 standard deviation of the mean? The 95. Or the 68.
Because 1 standard deviation, so you have the mean, and then 1 standard deviation would be the 2 on either side, which is 68.
I have that in my notes somewhere. Yes, it's 68. Okay, yeah, because 68 is 1 deviation, 95% is 2, and then 97. So it's 1, 2, and 3. Okay. Okay, number 9. Suppose random variable z has a standard normal distribution. Use the normal applet to answer the question. What proportion of the values from this random variable will be between -1 and 1? Give your answer as a decimal or accurate to 3 decimal places, e.g. if the answer is blah blah blah, you will answer da da da.
But it doesn't give us any numbers to plug in.
Yeah.
Use the normal applet. I would say it would be 68 again, or 0.68, because it's in between -1 and 1, which is those are standard deviations. So that is the percent of the data that would be in between. What proportion is a decimal? So 68 out of 100.
Okay, so if we use the deviation, or if it's between -1 and 1, which is 1 standard deviation, which is 68%, if you plug that into the normal probability applet and the area of 0.68, you get 0.468. What do you guys think?
The only thing is, I don't know. What proportion of the values will be between?
Negative.
The proportion of the values would be the area and not the z-score. But the only thing is, we would have to get the z-scores on 1 and -1.
Okay, so if you plug in 1 for the z-score,
Mm-hmm.
And the area would be 0.6827 or 0.683.
okay, so if we find the area on the applet between -1 and 1, the area is 0.6827.
Rounded to 3 spots is
0.683.
What proportion of the values? Proportion of the values, that's area, right?
Yeah.
Yeah.
Yeah, because we have between -1 and 1, so you want the middle of the graph shaded in, and you put the 1 in the z-score, and then you get 0.6827, which rounded to the 3 is 0.683.
Mm.
Okay, so the next one is the same except -2 and 2. Which would be your 95 percentile.
It's 0.955.
Three decimals.
Yep. Okay. Yeah, so I got 0.9545, which rounded is 0.955. Okay, so 0.955. And the last one is the -3 and 3. So which would be 3 at the bottom, which is 0.9973. Okay, Chelsea and Chancey, you're being very quiet.
Sorry, I'm working with the applet. I haven't got to use this yet. I'll have to watch the recording, so I'm still kind of learning as we go.
Okay. Do you understand how Mark and I got that though?
I'm watching and I'm making yes. So because I had a harder time when I went through this one. I need to go through it again.
Okay.
On this
Do you
one.
have any questions then that we can help you with?
Not that I can think of. I'm okay.
Okay.
I have to practice before I'm comfortable.
Yeah. Okay.
Me too.
So do you understand how we're getting the percentiles of the 65, 95, and 99.7
I think so.
rule? Okay.
Thank you.
Oops.
Okay, so number 12. Look carefully at your answers in the last 3 questions. What do you observe? The values. A, the values match the 68, 95, 99.7 rule. Okay, we ready for number 13?
Yeah.
Okay, the amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normal distribution in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. The population mean protein requirement for adults is 0.66 grams of protein, and the population standard deviation is 0.07 grams of protein. Use this information to answer questions 14 through 17. Okay.
So this is like what we were doing last time, I think.
I have to take my headphones off. I can't stand the echoing of myself. Okay. What portion of the population have a protein requirement that is less than 0.60 grams? Is less than.
Population
Okay.
protein that is less than 0.6.
Okay, so it's going to be less is all the way. Okay, so it's the left hand of the bell curve, all the way to the side. So that's less than.
Yeah.
So we're going to have to use the z-score to figure this out. Protein.
So the z-score is so it's 0.66 minus 0.6, because that's the
Yeah. Less than.
the number minus the mean divided by the standard deviation. So 0.66 minus 0.6 divided by 0.07, that's 0.857. So that would be the z-score, right? So plug the z-score in, and it's how many is less than that?
Less than
Portion of
0.06.
population is less than 0.06. Oh, wait a second. I think that z-score's wrong. Hang on.
Yeah, I'm confused on this one. Let's see.
Negative 0.857.
I don't know.
I think it's 0.804. Because the z-score is 0.857. And so you plug that in, and then it's everything less than.
Okay, so how did you get your z-score? You plugged it into the z equals.
So the z-score formula is the z-score equals x minus the mean divided by the standard deviation. So in this case, we're trying to find the z-score for 0.6. So it would be 0.6 minus the mean of 0.66 divided by 0.07. So that z-score is negative 0.857. So everything less than that would be 0.1957 or 0.196.
What did you get for your z-score?
I got negative 0.857.
Okay, that's what I got too. Okay, then we have to take.
You have to find the area of everything below negative 0.857.
Okay, so you can put in the applet.
Mm-hmm.
Oops, wrong one.
Okay, so I got the area is 0.1957.
Yeah, and then rounded to 3 places is 0.196. Is that right? That's what I got. I'm not sure. I think that's right.
This is hard.
Oh, yeah. I'm definitely going to have to go through some of those videos again.
Okay, so the mean. It's 0.6. Okay. I'm just double checking everything before we finalize this. Okay. Okay. I think that's right.
96.
0.196. Okay. Question number 14. What is the portion of the population have a protein requirement that is more than 0.6? So more than.
The other shaded areas. So
Yeah.
that's 0.804. Is that what y'all's showing?
More than. So, okay, so Z equals. How did you set up your problem, Mark?
I
Because it's more.
So for this one, I did 0.6 minus 0.66 divided by 0.07, and that's negative 0.857.
Mm-hmm.
So I plugged that into it, negative 0.857, and then it's asking for the population that is more than 0.6. 0.6 value is the negative z-score, so it's everything to the right of that. So it would be 0.804. But if you think about it, you could just subtract 13 and 14, or subtract 13 from 1. So 1 minus, because this is asking what is less than 0.6 and what is more than 0.6. Those two have to equal 1. So 1 minus 0.196, what is that? 1 minus 0.1. Yeah, I got 0.804 again.
Yeah, me too. Okay, so you said you've got to find your z-score the same way you did before, which is the negative 0.857. And then you plug that in 0.057. But then you want to find the more. So it's all the way to the right of the bell curve. How did you find that? So I got the z-score of negative 0.857.
That should be your left z-score, which is the z-score for the 0.6. So if you want to find everything that's more than that, then you would want the right of that second or that first line. But make sure that you only have so the far left is white, and then the other two should be blue, because that will be the proportion that's greater than that z-score that represents
Okay.
0.6.
So you get 0.8043.
That's what I got, but rounded to 3 decimal places is 0.80.
0.8. Well, it's right, and then if you take the 1 minus the answer number 13 is 1 or 0.196, you get 0.804.
Right.
Okay, so it's 0.804.
That's what I put.
Yeah.
That's about as good as I can do.
Okay, so what portion of the population has, okay, so number 15, what portion of the population has a protein requirement that is less than 0.7 grams? Okay, so okay, so I find your z-value, or z-score, which is the same as it was before, which is negative 0.857. And you want to find less than 0.70 grams. So we go over to the applet, which is, what does it say? It's 0.7? Is it 0.70? Okay, so 70, your area is going to be, you want to find the 0.70%. And it is less than 70. So you want to shade in the middle and then all the way to the left.
Right.
Is that right, Mark? Okay. And then the area is 0.6999.
Wait, I got a different one. What was your z-score?
Yeah, it's the same as it was. Wait a minute.
Z-score
It's
should be
less
different.
It's going to be different. Less than.
It should be 0.7 minus 0.66 divided by 0.07, because you've got a new value now.
Yeah. Okay, so it's 0.7 minus 0.66 divided by 0.07 equals, hold on a second. Okay, so it's negative 8.728.
Wait,
What?
I didn't get that.
You didn't get that?
No, 0.7 minus 0.66.
66 divided by
0.04. So 0.04 divided by 0.07 is 0.571. Did you plug all of your numbers in at once? Because your calculator might have done one operation.
It did something jacked up.
So try doing 0.7 minus 0.66.
yeah,
Okay, 0.7
0.04.
minus 0.66 equals 0.04.
And then divide that by 0.07.
Okay, so that's
0.57.
0.571.
571. Yeah, so that should be your new
Okay.
z-score.
Okay, so that's my new z-score. So you put that in 0.571. Okay, and then you want that's less than 0.7. Okay, which is your area is then 0.7160.
That's what I got.
You
Wait,
round
what?
it to the round to the 3 decimal places is 0.716.
Yeah, that's what I got.
Is that what you got? Okay.
I followed that one for once.
0.716. All right. Number 16. Find the probability that a randomly selected person will have a protein requirement that is between 0.6 and 0.7. Okay. Okay, so hint, remember that to find the area between the two values, shade the area to the left of the z-score, you calculate and then subtract the small area with the larger area. Make sure your answer is positive. This is the probability that a randomly selected observation will lie between the two values. Okay. Okay, so we have to find the or the middle section of it.
Okay, so should be 15 minus 13. Because
Yeah.
like if you wrote it out linearly, it would be 0.6 is less than x is less than 0.7. So everything that was less than 0.6 was 0.196, and everything that was less than 0.7 was 0.716. So 0.716 minus 0.196, I got 0.52.
Okay, so you're taking the number 13 answer and number 15 answer and subtracting those two to find the middle, right?
That's what I'm doing.
Okay. Equals negative 0.52. Is that what you got?
I got 0.52.
Yeah, because it said it has to be positive.
Oh, it has to be positive. Oh, I did it backwards. Okay. .52. So then you go over to the applet, and you want to find just the middle. So you're putting your .52, and you highlight just the middle, and then it's .3969, and then rounded. It's .397.
What did you get? 3969?
It's yeah, I got .3969 round to the 3 decimal places is .397.
97. Yeah,
What did you guys get?
I got that. 0.397.
Mark, what do you get?
I got 0.389. No, I'm sorry. 0.50. How did you get 0.397?
I took the .716 minus the .196 equals .52, and then I put .52 in the z-score, and I highlighted the center of the applet.
Yeah.
Is that what you got, Mark?
So the z-score was 0.52.
Yes.
That was what you put in for the z-score?
Mm-hmm.
Yeah, .52.
0.52 for the z-score, and then the middle, you got...
And then I highlighted only the middle.
9, 7. But is
Yeah,
that...
so I got, well, .3969, and then rounded to the 3 places is .397.
The only thing that I'm wondering about is it just says to find the z-scores and subtract them and make your answer positive. This is the probability that will.
Oh, so this is
So I think it's
0.52.
0.52. I think
Yeah.
when you put 0.52 in as a new z-score, then you are no longer working with 0.6 and 0.7. You're finding the area that's between positive
Oh,
and
yes, that's right.
0.52.
Yeah, you're right. I didn't read the question. We're just finding the z-score, not calculating the area.
Oh.
Well, you're calculating the area between two z-scores that you've already figured out with their corresponding.
Right.
So 13 through 15 are areas that you've already found. So all we need to do is subtract out the fluff of the extra areas. Because right now we've got two bell curves that are 2/3 shaded, and we need to get it to where we only have that middle section.
The
So we
middle
would
section.
take the 2/3 minus that last 1/3, and that would give us the middle part. Does that make sense?
Right, because if you take the 0.196 plus the 0.804 plus the 0.176, oh, that should equal. Shouldn't that equal 1? Well, no, it shouldn't because it's the area of the bell curve. Never mind. Okay. Okay, number 17. Find the 35th percentile for the protein requirements for adults.
So for 16, it was 0.52?
Yes.
Okay.
Man, I'm glad I have you guys. Because I'd still be sitting here going like, what? Okay, so number 17. Find the 35th percentile for the protein requirements for adults.
So you should just put 0.35, or yeah.
Yeah, in the area.
For the area. The z-score is 0.454.
4. Yep.
Yeah.
Is that what y'all got?
Yep.
Yeah, 454? That's what I got.
0.454. Yes.
Yeah.
And then what's the 80th percentile? And then just go back to your applet into area and put 0.0 or 0.80 for 80%, and then it's 1.282.
That's what I got.
1.282?
Yep.
For the z-score, right? Yeah.
Yep, 1.282.
0.2.
Okay. So I'm saving for later now. I'm going to do that forever now. No, that's that's what they should tell you is.
Well, on all of my classes, that's what they
lose all your answers.
Yeah, most of my classes have told me that. This one I haven't seen anything on that here, but
I haven't seen any of that. I haven't seen that anywhere in any of my classes, and this is what semester? This is my like 4th or 5th semester online.
Oh, go. Yeah, because I think this is my 5th or 6th.
Where are you guys? I can't find you guys. Ah, there you are. Nope, lost ya.
Okay, so who's feeling brave enough to submit first this time?
I'm scared.
I'm scared. True.
I'll go for it.
No, I found you guys. I don't know what I look like when I'm thinking and doing math stuff, but that probably recording is hilarious looking. I just have too many windows pulled up to find it, you guys. Okay. Hey! I found you.
Hi.
Okay, so who's brave to do it?
Okay, I'll do it. I'll do it if we can just run through the answers I wrote down.
Okay.
Starting with number 3, 1, false, true. C, B, 68.683. Number 10, 0.955. Oh, I didn't get number 11.
Number 11 is 0.997 is what I got.
We don't have
me
to.
too.
Oh, yeah, because we're rounding. That's right. Good thing we went through that because I left the 3 at the end. Nope, you don't need that.
Okay.
I'm just
Point
running to
nine-
2 decimal places and not 3, so this is throwing me off. But anyways, okay.
Okay. So 11.997, 12 is the first one. 13.196, 0.084, 716, 16.520, 17.454, and 18.1.282.
Does it matter? Do we have to put the 0 on number 16, or is it 0.52 okay?
I would just because it asks for 3 decimals, so it might be programmed to look at the 3 numbers.
Okay.
Oh, good point, Mark.
Okay. Okay.
Ready?
Okay.
Okay, here we go. %. 17 and 18 are off.
Oh.
What?
But all the rest of them are right?
Mark's like,
Yes.
I'm good with 90.
No, I need to get it 100 because I need to bring my grade back up. I need to maintain my
100.
full scholarships and junk.
Okay, so 17 and 18. Find the 35th percentile for the protein requirements for adults.
The 35th percentile. So we need a z-score.
I have to open that program again.
How did we do that? I feel like we did that during the group work or something.
Yeah, I gotta find that again. Where did that go?
I know. I think I already started closing out of everything.
What is the third? Oh, I think we need to do instead of. I think that's the one where we do like x equals the mean
Wait,
plus
what?
4 times.
Oh, yeah, that crazy algebraic stuff. Is that what you're talking about, Mark?
Yeah, I think so. Because the z-score, right? How do we do it with the other ones?
Okay, so it's number 6, letter D. Is the 10th percentile. That's what that's talking about. Okay, so we do need to use the applet and put in the 10%.
I gotta open up
Or
that
the
applet
35th
again.
percent. The 0.35.
Yep, 0.35.
Okay, and then the z-score is 0.454. So then that's
Yes.
okay. So the mean is the mean is 0.6. No, this is a different one. Yeah, no, this is okay. 0.6 plus the z-score is 0.454 times the standard deviation of 0.07.
Okay. Let me go back. Hold on. You're ahead of me, Mark, again. Okay, so
0.6.
and so we're looking for x equals x subtract 0.66 over 0.07
Is it?
equals.
Oh, it's 0.66.
Yeah, it's 0.66
Okay.
over 0.07, right?
Yeah. Wait, no, because we're solving for x. So the formula, instead of d equals x plus the mean over the standard deviation, it would be x equals the mean plus the z-score times the standard deviation.
Correct.
So it would be the mean is 0.6 plus 0.454 times 0.07 equals 0.6917, so 0.692.
92. Yeah.
What? You lost me.
Okay, so the z-score for the 35th percentile is 0.454. We found that by punching in 0.35
Right, and then
getting the z-score. So
that equals x subtract 0.66.
Well, you wouldn't be subtracting. So what you would do is you would take the z-score. So you take 0.454 times the
Yeah.
standard deviation, which is 0.07, and
Okay.
that is 0.03178. Then you take that and add the mean, which is 0.66. So 0.03178 plus 0.66 is 0.69178, or 0.692.
0.69. What was that?
0.692. That's what I got.
Yeah, that's what when I added that up too. That's what I got as well.
Okay, hold on. Let me figure this out.
I feel like it's always the second lesson that takes us the longest.
Yeah. Okay, so why did you multiply the
0.7?
the z-score times the 0.7?
So you
Oh,
have
because that's a
to.
standard deviation.
Well, the reason that we did that this time is because we're not trying to solve for the z-score. We're trying to solve for the x. So you have to change the
Oh.
formula that you use. So you're not going to do x minus u divided by the standard deviation. You have to switch it. So to solve for x,
Oh,
the
yes,
formula
okay.
is x equals u plus, I'm calling it u, I know that's not the thing, but u plus z times the standard deviation. That would
Okay,
be,
so
like, after the algebra switching and everything, that's the formula that you got to use.
okay, because division becomes multiplication, and then subtraction comes addition. Okay, I gotcha. Yeah. Okay, so number 17 is 0.692. Is
Yeah,
that
that's
right?
0.692.
Oh, what was an 18 we had wrong too, right?
Right, we
Right.
got the z-score, and so the z-score was 1.282. So we would need to multiply that by the standard deviation, which is 0.07, and then add that number with the mean. So I got 0.74974, which would be, after rounding, it would be 0.750.
Okay, so you have to go back into your applet and put in the 0.80, right? To get the 1.282,
Right.
and to get your z-score. And then you need to multiply that by 0.07, right?
Right.
Plus the 0.66.
Yeah, 750.
Plus 0.66 equals 0.749.
0.7497. Rounded to the third place would be
Oh.
0.750.
Okay, so 0.0750. Okay, because I got, yeah, 7. Okay. All right. We ready to submit that now?
Mhm.
After I save it for later? Hold on.
Okay, hold on, guys. I already submitted it. They're both still wrong.
What?
Are they really?
Yep. 17, we had 0.692, and then 0.750. They're both wrong.
How are they both still wrong?
Ugh. What did we do wrong?
I wish I would show you that part.
I know, right?
How to fix it?
We should just only get the multiple choice wrong.
Well, these fill in the blank are tough, man. Okay.
The 35th percentile. How do you...
Okay, 30. So we have the applet is right though. So the 0.35 is still the 0.545.
What if, so 0.35, the z-score would be negative 0.454, right? Because it's the 10th percentile. So would it be the lower number?
Yeah, well, because we're looking at the 35th percentile. Oh, it would be 0.385 for the z-score. Because we're looking at the 35th percentile, which should be highlighted all the way to the left. So it's 0.385 for the... okay.
How are you getting 0.385?
Because I highlighted only to the left because it's 35% and under, right?
Oh.
And so it's 0.35
Yeah, I
on
didn't do
top,
that.
highlight all the way to the left, and leave the other two unhighlighted, the middle and the all the way to the right. And then the z-score is 0.385. That's what we're doing wrong.
I just got that also. Okay.
Times, and multiply that times the 0.07
Negative 0.38.
plus 0.66.
0.633.
Hold on. Oh. It equals 0.7139, which rounded is 7.
I didn't get that. So it's negative 0.385 is the z-score times 0.0.
No, I got positive. Well, actually, it would be negative because we're doing the negative 35, the 35% and under. So it would be negative 0.385 times the 0.07 plus the 0.66.
Right. So negative 0.385 times 0.07 is negative 0.02695. Plus 0.66 is 0.63305. At least that's what I got.
Hold on. .633, is that what you got?
That's what I got, yeah.
Okay, that's what I got too.
So let's try and do 80th percentile and see what we come up with.
Okay. Okay, so 80th percentile, 0.08, and we want to go all the way to the right, shaded.
It wouldn't be 0.08, it would be 0.8.
Or, yeah, that's what I meant.
Okay. So 0.8 shaded to the left. I got a z-score of 0.842.
That's correct, yeah.
Okay, so that times 0.07.
Plus the 0.66.
Plus 0.66.
What is that?
I got 0.7189. Or 0.719.
Yep. Well, it's 0.718. Rounded is 0.719.
That's what I got. Okay, I'm gonna submit it, and then it's just whatever.
Okay, hold on. Hold on. I'm saving it now.
Okay, that's it. Yeah.
Is that right, Mark?
Yeah, that's right.
It is? Woohoo!
Oh, you too.
Yay! Holy crud. Okay, so now I'm so confused. I don't know how to do that now. Because we did it like, what, 3 or 4 different ways to find the right answer?
Yeah, that was bad.
Oh, okay. Where is my... There you guys are. Okay. Where... Okay, do we have anything else we need to talk about? I'm going to stop recording then, okay? Are you guys okay with it?
Yep.